Okay, yesterday we have derived the standard equation of parabola y square is equal to 4x and derived equations of tangents, point of intersection of tangent, focal chord, condition for being focal chord, parameterization of the parabola, how parameter t is related, so etc. And we have found out equation in terms of parameter, then auxiliary equation for finding out slopes. Now find the equation of normal. At Pt and express it as y is equal to equation of normal to y square is equal to 4x. Equation of normal is minus tx plus 2at plus 80 q. Second, the way we write equation of tangent in terms of slope, find the equation of normal in terms of slope m. M is the slope of normal now. The equation of normal will look like. Second, third question in this, find foot of normal in terms of m. दाखवा. In one, we have found out the equation of normal in terms of t. Now you have been given slope is equal to m, which is minus t here. Therefore, equation of normal in terms of slope m would be y is equal to mx minus 2am minus am cube. Okay. And then you know the point, 80 square comma 280. That is what was your point from where you are drawing normal. That is what is your foot of normal. Replace t by opposite of m. You get foot of normal as am square comma minus 2am. Okay. Now, what are we trying to do? We are trying to, there is a parabola and we are trying to do normal. This is tangent, perpendicular line. Okay. So the next question is going to be for, suppose I give you some point p x1 y1. And I wish to draw normals to the given parabola. Suppose you have been given any point x1 y1 and you are interested in finding out equations of normals to this parabola. So find auxiliary equation. In terms of slope. In terms of slope m of the normal. Of normal. So by solving that auxiliary equation, we will get values of m, and hence we have a point with us. If we have a slope, we will be able to find out equations of normals. So get me the auxiliary equation is equal to 0 form. Something is equal to 0. You already have this equation with you at Pt or at parameter t. This is the equation that you have. If we want it in terms of slope, we converted it into this form. These are put up normals. Now this normal is required to go through point x1 y1. Therefore it is the same equation except replacing x by x1 and y by y1 and simplifying, you get the desired auxiliary equation. So am's cube, right, plus something times m plus something. What is inside? 2a minus x1. This is the auxiliary equation. And then if we look at this auxiliary equation, few things are very easy to identify. One, what is the interpretation of this? If we solve this, we get to know three slopes, if at all, if we can solve it. So the interpretation of this is, in general, there will be how many normals? Three normals from any point on to the parabola. Second thing that we could collect from this information is sum of the slopes of these three normals is going to be equal to 0. Yes or no? Now this m that we have found out, so let us say m1, m2 and m3 are the slopes of three normals. We come to know that m1 plus m2 plus m3 is equal to 0. But then our m was opposite of t. If parameter t is of the foot of normal t1, so minus t1 minus t2 minus t3 is equal to 0. And therefore sum of the parameters t1 plus t2 plus t3 is 0 if you draw normals from these 3 points, if you want them to be concurrent, co-normal. Okay, concurrent. I mean, on parabola you have T1, you have T2, and you have T3, suppose. These are the three normals that you can see you have drawn, because you have to have perpendicularity here, perpendicularity here, perpendicularity here, right? So then it is guaranteed that this T1 plus T2 plus T3 numerical values, if added, they get 0, they become 0. Okay. Conversely, may not be true. Okay. They are supposed to be concurrent. They are supposed to be concurrent. T1 plus T2 plus T3, 0 is one part. But then if I arrange T1, T2, T3 in such a way that they become 0, does not mean that all three normals are going to be concurrent. So in opposite direction, it might not be true unless and until you found out those T1, T2, T3 by considering the foot of normals, feet of normals. Wait, have you understood this? So by looking at the coefficients of this cubic in M, we can infer few more things. And the most important is sum of the slopes is going to be 0. Of course, m1 m2 plus m2 m3 plus m3 m1 is this 2a minus x1, and product of the slopes 2a minus x1 upon a, that is sigma 2, and sigma 3 is going to be minus y1 upon a. Product of the slopes is going to be y1 upon a with negative sign. That you may want to register that it is there, that information is there. Okay. Assume that a is greater than 0. Fourth or fifth problem. The number of normals from k comma 0. Maybe I am taking a point on x-axis to parabola y square is equal to 4ax. A is positive. Okay. I am supposed to write something after this. If A is positive, the number of normals from k comma 0 to parabola y square is equal to, you have to characterize this. K is going to move from 0 to maybe plus infinity. So when will you get normals? How many normals? How many distinct? How many coincident? All the characterization of normals. If the point is k comma 0, figure out what is going to happen and show me your result in concise form. We will develop that, but I give you 5 minutes to think and dig out your own result. What we are trying to find out is, as this k moves on x-axis, suppose there is a somewhere, a here, a comma 0, and now this k is moving. K can be here, k comma 0, or it can be with 0 to infinity. It can move anywhere, and then we are supposed to find out the nature of the normals that we get. Okay, so we have got auxiliary equation. Here is our auxiliary equation. Here is our auxiliary equation. Am cube plus 2a minus k. X1 is k. M plus 0 is equal to 0. That makes things little easy. M common inside bracket, am square am square plus 2a minus k is equal to 0. Is that right? Therefore, of course, m is equal to 0 is one normal, and okay, that normal is there. This is the normal. X-axis itself is a normal, m is equal to 0 having slope. So m is equal to 0. We have one normal, one real normal will always be there. That is x-axis. Good. Now, remaining two normals will be there or not will depend on the minus error in the equation, correct. So what is the discriminant of this? So discriminant of this equation delta is equal to or maybe I think it is easy, no? Okay, but anyway, discriminant of this is coefficient of m is 0 square minus 4 into a into 2a minus k, that is काय करायचं आपल्याला, remaining two slopes पाहिजे आपल्याला. So if this is equal to 0, then we have coincident real two more. If this is equal to 0, what is happening? 4 is gone. 2a square is equal to k. आहे त्याच चुकलंय का ते?
A is equal to k.
Huh?
2a is equal to k कारण की a greater than c.
Okay. Sorry. Sorry, I have to do this. 2a is equal to k. So if k coincides to a, if this is focus, double the distance, then all the three normals will be having is equal to 0, m is equal to 0, all three. So if k is equal to 2a, so that is the deciding factor. And then if if this equation, which is 2a minus k, is greater than 0, that is second condition. 2a minus k is greater than 0, you have two more distinct. So 2a is greater than, नाही चुकते काहीतरी, इथे माइनस साइन है ना, so inequality will flip. Therefore 2a is less than k, two more distinct. K is greater than 2a, two more distinct, and the remaining is 2a is greater than k, two not real. Okay, so is the characterization complete? Yes. Now let me show you in this diagram. If you are sitting at this point, three coincident real normals, that is this only, three times. If you are away from this, three distinct. And if you go towards this side, then one real, two imaginary. Now, two imaginary are going to be distinct, but you cannot draw them, but they are not same. They are distinct. And if you are away from 2a, then you can very well see that they are there and they are going to be symmetric with respect to x-axis, and everything is fine. So this characterization must two more distinct, two not real, and all three coincident. This is what is the characterization of normal, and it all depends on whether you can solve Q. Suppose this point is anywhere here, then can you tell the future of the normals, how many will exist, etc. will depend on the cubic that you solve, whether it is solvable cubic or not, and what is the future of roots of this cubic expression. We need to learn something more about cubic, which we will learn eventually. But at the moment, if the point is good, it is on the x-axis, then we can characterize it and tell about the normals that we get. Questions? Any questions? Doubt? Find the point of intersection of the normals at P1, T1, P2, T2. भरपूर काम आहे तुम्हाला, करा. It is not difficult task, but it is little long. So you have to write down equations of normals, solve them simultaneously to get x coordinate as 2a plus a times t1 square plus t1 t2 plus t2 square. This is x coordinate comma minus a t1 t2 t1 plus t2. Now these are the things which you are required to remember, because if suppose some locus of point of intersection of normals is required, this is going to be very handy. You need not have to work again. If you remember this point, you can exploit the nature of this point to find out that locus. Okay, next. Now, by doing this, we have got a parabola. Okay, and a parabola is strange. Y square is equal to 4ax. Very bad, not homogeneous, not consistent, nothing special about this equation, and therefore calculus is all about study of any curve, study of any complicated curve at any point. Suppose this is a complicated curve that we have, which is parabola, and I want to study at this point what is happening at this point. But then I don't want to deal with such a bad expression. After calculus, what we will realize that instead of dealing with such a bad expression locally at say x naught comma y naught, it is okay if we deal with corresponding tangent at that point. Corresponding tangent at that point locally. We can consider this curve and approximate it by this tangent in the neighborhood of x naught comma y naught. And the moment it is a straight line, it is easy to deal with. Properties are known, and because it is a linear equation in x and y, easy to handle. This curve is also relatively easy, but there could be higher degree, higher order equations whose curves are going to be really complicated, and it is going to be very difficult to know something more about that curve at a specific point, and therefore differential calculus will tell us that you need not have to worry about that curve. Just check what is the tangent. Does tangent exist? And if it is existing, then you can locally approximate that curve by a straight line in the very small neighborhood of that point. That is what is called calculus all about. We will learn it very systematically, but presently, and that is too bad approximation, because you are really considering the curve by a straight line. So you are considering it straight line because this straight line is easy to handle. Maybe one level up approximation if we want to do, what we wish to do is, maybe we will try to fix a circle. We will try to fix a circle because circle has got some curvature, and therefore we will there will be infinitely many circles which will be tangent to the curve at that point, and every circle will have a different radius, and we have to say for example, this almost looks like a circle, so I can have a small circle here which will approximate this curve at this point, and then dealing with circle is easy for me rather than dealing with complicated curve like this. Okay, so the closest circle, best possible approximation of a curve by a circle. In that case, that circle will be called circle of curvature. And the radius which you will arrive at is called radius of curvature. Okay, to give you an example, I don't know, you are not subjected to driving test yet, but in a driving test, I mean, you are asked to complete 8 or something like that. And then uh, if you turn your vehicle too much, then you will not follow this route. If you turn too less, then you will go and hit, and therefore the curvature of this road is managed, especially in ghat. The road is slant like this. Okay, इकडे डोंगर, इकडे दरी, आणि तुम्ही वळण घेताय असं वळण. Okay, so if you look at the cross section of that road, it is not horizontal. It is not horizontal. It is at some angle, slanting of the road. And why that slanting of the road is created is because you should be able to turn in that ghat region very quickly. The radius of curvature reduces, and you can take a local turn, which if it was a flat road, you won't be able to take that rotation, that curvature. Your radius is going to be more. So, I mean, there are enough calculations in physics to find out what should be the radius of curvature and what should be the slanting of these roads, etc. But what we are interested right now is, suppose we have been given a curve, which is the best circle which will approximate the curve at that point. That is what we wanted to find out. We will call that circle as circle of curvature, and corresponding radius will be radius of curvature. And hence, the best way, what do you think should be the method for finding out this radius? Because there are infinitely many radii available which will represent the circle and be tangent at that point, but one which is best approximation. How do we find out? And it is very simple idea. Again, a limiting idea. What you do is, if suppose you want to find out radius of curvature at this point, you take a point nearby. Say this is P naught, X naught, Y naught, or P naught, T naught is the parameter of this. You take any other parameter P1, T1 in the neighborhood of that point, then draw normals. This is a normal at P naught. This is normal at T1. Okay. And because it is a curve and it's not a straight line, if it is a straight line, then these two lines will be parallel, normals will be parallel, but then we need not have to study straight line. If we are studying curve, then these normals will intersect. And then if you take this, I mean, normals will intersect at point to one point, and then what you are supposed to do is take this T1 along the curve to T0, limiting the way in degree 2 equation we have found out the slope of tangent by limiting case. And then this point of intersection will be there somewhere. I mean, if you take this T1 along the curve to T0, in limiting case, you will end up getting the circle and the radius of the desired nature. Am I clear what I am trying to tell you? It's center of circle of curvature is 2a plus 3a T naught square minus 2a T naught cube. This is center. Yes, happens to be 2a inside bracket 1 plus t square raised to 3 by 2. You have to get this because this answer is here. This answer is here. T2 goes to T1. T2 becomes T1. So do you get this? And then what is remaining is finding the distance of center from P naught. That comes out to be equal to this. So it is actually easy, having done the hard work already for finding out the point of intersection. If we call T1 as T0 and T2 goes to T0, then we get this. Here also we get this. So center is over. So this is the center, and radius is going to be distance of this point a T0 square comma 2a T0. Radius is going to be distance from these 2 points, and after simplification you will get it like this. That is your radius of curvature. Point number 7 of today's lecture. Normal at P1 meets the parabola again at P2 T2, where T2 is equal to normal at T1 meets the parabola again at T2. So what do we do? T2 should satisfy the equation of normal at T1. Is that correct? So equation of normal at T1 is equal to y is equal to minus T1x plus 2a T1 plus 81 cube, and this should be satisfied by T2. T2 means a T2 square comma 2a T, and then we have relationship between T2 and T1. We should simplify and get the answer. 2a T2 is equal to a minus a T1 T2 square plus 2a T1 plus a T1 cube. Is this right? I think so. A vanishes from everywhere, and 2 एके ठिकाणी नाहीये. So what do we do now? We want T2 in terms of T1. We want T2 in terms of T1, so we should write quadratic in T2. Is this correct? So T1 T2 square plus 2T2, that is what this is done. Then these two guys go to LHS, minus 2T1 minus T1 cube is equal to 0. Therefore T2 is equal to, is it so complicated? Maybe. T2 is equal to minus B plus minus under root B square minus 4AC. I don't know, there must be some shortcut, but let us do it. Okay, so this is good quantity, it seems. Minus 2 by T1 is 1, and then what is there inside the plus minus radical? 4 plus 8 T1 square plus 4 t1 raised to 4 upon 2t1. Good. So minus 2 upon t1 plus minus. Is this a perfect square? Yes. And therefore square root of that 4 comes out and 2 disappears. So this is t1 in the denominator and it is a perfect square of t1 plus 1. I don't know, I'm messing it up or is it correct?
T1 square पाहिजे तिकडे.
Is it correct? Correct चाललंय? काय मदत कर
सर तिथे T1 स्क्वेअर पाहिजे.
स्टेप मध्ये T1 स्क्वेअर प्लस 1 पाहिजे.
इथे आता बरोबर आहे. अरे हॅलो आता बरोबर आहे का? पण मग प्लस मायनस कसं उत्तर येते माझं? एक कॅन्सल होणार, एक स्वतः T1 शिल्लक राहणार का? T2 इज इक्वल टू T2 येणार का? काय?
सर आणि तिथे पहिल्या टर्म मध्ये -1 अपॉन T1 पाहिजे. ते 2 कॅन्सल होणार.
हो सर.
येस सर.
हा -1 पाहिजे. बरोबर. This should be -1. This should be -1. And what happens to this?
सर मग एक टर्म T1च येईल आणि दुसरी टर्म वेगळी येईल.
That is what I am expecting. So minus, the final answer is -2 upon T1 minus T1. Is it what I am getting here? Let us see. -1 upon T1 plus T1 plus 1 upon T1. So that is equal to T1. So 1 point is correct, na? 1 point it is intersecting the parabola at T1. So you can call that as T2. Fair enough, but we are not going to do that. Therefore, second point is 1 upon T1 minus T1 minus 1 upon T1, which is equal to minus T1 minus 2 upon T1. Ah, correct. Very good. आजकाल माझा कॉन्फिडन्सच जरा कमी झालाय अल्जेब्रावरचा.
सर
बोला.
सर मग आपण त्याच्यापेक्षा ते
Chord P1 P2 subtends right angle at vertex. If now P1 is P1 T1 and P2 is P2 T2. So find the condition on T1 T2 so that P1 P2 chord subtends right angle at vertex. You know on parabola PT1 is equal to AT1 square comma 2AT1. Vertex is 0 comma 0. And other point on parabola PT2, P2 T2 is AT2 square comma 2AT2. And they are supposed to be 90 degree at each other. So slope of this into slope of this, and it is 0 comma 0. So 2AT1 upon AT1 square into 2AT2 upon AT2 square. These are the slopes, should be -1, and you end up getting T1 T2 is equal to -4. A gets cancelled. It is independent of parabola. I mean independent of focus A. Next, if normal 9, if normal set P1 T1 and P2 T2 once again meet, on the parabola. Then T1, T2 is equal to how much? Array, I should not have given this also. Okay, so the idea given by the student is let PT be the point of intersection. What is happening that geometrically the problem is you are drawing normal here and it is in, I mean, now you are drawing two normals and those two normals intersect again at parabola. So this is P1, T1. This is P1, T1. This is P2, T2. And this is PT. Okay. And it is also on parabola. So PT be the point on P. So by previous condition, we know T is equal to minus T1 minus 2 upon T1, which is also equal to minus T2 minus 2 upon T2. And if we simplify this, we get T1, T2 is equal to 2 and not minus 2. That is the easier way of doing it because we have already developed that. You can have a point of intersection of these two and you can make that point satisfy parabola. Again, you will get exactly same condition, but calculations will be longer. Okay, next 10. Slope of chord P1, P2 is very easy. Write down what is the slope of chord of P1, P2. P1, T1, P2, T2. 2a T1 minus 2a T2 upon a T1 square minus a T2 square, which is equal to 2 upon T1 plus T2. 11. Definition. Locus of midpoints of parallel chords is called diameter. Okay, now this is new definition of diameter which works for circle because we know the property of circle that midpoints of parallel chord locus is going to be diameter. It is true for circle, but now we are going to talk about diameter of parabola, diameter of ellipse, diameter of hyperbola. And so far we have been using the word diameter for only circle, and there it was obvious chord passing through center is diameter. That was our definition there. But now this is more general definition of diameter. Locus of midpoints of parallel chords is a diameter of that parabola. Okay. And therefore, find the equation of diameter. Find the equation of diameter. find the equation of diameter. If slope of parallel chords is equal to m. Parabola is y square is equal to 4ax. Okay, so let me just explain you what you are supposed to find out. We have a parabola, and if you happen to draw chords of slope m, slope of this chord is m, there will be infinitely many chords, right? And if you try to join the midpoints, then you will get the locus of midpoints, that will have some equation. Find the locus and the equation of the midpoints of parallel chords having slope m. That will be our equation of diameter, because we have defined diameter as locus of midpoints of parallel chords. Let midpoint of any one of the parallel chords is x dash comma y dash, and we want locus, therefore that is our representative point, x dash comma y dash, and therefore what I can do is, what is the equation of this chord? The equation of the chord is going to be y minus y dash m into x minus x dash, where m is slope given to us. Now, as far as parabola y square is equal to 4ax is concerned, we know method of finding out equation of this chord directly. Equation of chord in terms of point t is equal to s1. Is it correct? See, t is equal to 4 interpretations. T is equal to S1 midpoint, and T square is equal to SS1 joint equation of tangents. These are the three special things that you are supposed to remember. T is equal to 0 has got 4 interpretations. T is equal to S1 is the locus. T is equal to S1 is equation of chord in terms of midpoint, and T square is equal to SS square is joint equation of tangent. So right now we are doing equation of chord in terms of midpoint only. So T for this parabola is y1 minus 2, sorry, not y1, y dash minus 2 is 2a inside bracket x plus x dash. That is your T. And what is your S1? S1 is put that point into the equation of parabola. So y dash square minus 4a x dash. This is the equation of the same chord. So let us write it again. Y dash minus 2ax minus 2ax dash minus y dash square plus 2a plus 4a x dash is equal to 0. So now x is present at one place, minus 2ax, y is present at one place, plus y dash y, and the constant is minus 2ax. Oh, sorry, what is this? Y dash square, this minus charge plus 2ax dash minus y dash square is equal to 0. Okay, and here what is our, the same chord we have got by some other method. So by comparing coefficients we should get some idea about what we are doing. So coefficient of x here is mx, coefficient of y here is minus 1, and the constant here is minus mx dash plus y dash is equal to 0. These two equations are of the same chord. It is of same chord, and therefore by comparing these guys should be proportional. So minus 2a upon m should be equal to y dash upon minus 1 should be equal to the constant upon constant, but it might not be of some use to us. You can write it, and therefore what we get is y dash is equal to 2a upon m. अरे समझते का? That is where the story ends. We get the locus. Y dash is equal to 2a upon m, constant. This is constant. The moment you give me the slope of chord, I give you diameter. That is one way of doing it. Equation of diameter. Replacing y dash by y, we get the desired equation. So all the diameters of parabola that we are talking about are going parallel to x-axis. That is the outcome of this. All diameters are going to be parallel to x-axis. Moreover, one thing which we can learn out of this is, suppose in the limiting case there will be a point here, this chord length is becoming lesser and lesser as you go near parabola, and eventually you will hit a point and which you have to call as a chord, and then if you draw parallel chord there, it will be actually tangent at that point. Correct? It will be actually tangent, that is the limiting secant. So it is going to be tangent at that point with the slope m. So what I wanted to tell you is diameter cuts the parabola at the point where the slope of the tangent is going to be m. We need to make note of this. Okay, so let me check whether everything is shortest normal chord. Shortest normal chord corresponds to t is equal to, and what is its length? Do you understand? Shortest normal chord means you draw a chord, at least it should be normal to the curve at one point. It is not going to be possible that it is normal to both the points. It will be possible to have a shortest chord normal to one point. Say this is a normal chord. At this point it is normal and it's t. So at square comma 2at. Then this is suppose t1. Then we know t1 is equal to minus t minus 2 upon t. Okay. So coordinates of this is going to be 8t1 square comma 2at1. Therefore, in terms of t, it will be a into minus t minus 2 upon t bracket square comma 2a into minus t comma minus t minus 2 upon t. Okay, and then this distance that we are supposed to find out, distance square is equal to 2a into minus t minus 2 upon t minus 2at bracket square plus a into minus t minus 2a upon t bracket square minus 80 square bracket square, and we want to minimize this. So let us just simplify this first and find out what we get. Is there any cancellation taking place? No cancellation. Okay, so minus 280 minus 280, so minus 480, and you have minus 4a upon t bracket square plus minus 80, this is square, so minus 280 square. No, I think there will be cancellation here. A inside bracket t square minus 1 is gone, so plus 4 plus 4 upon t square minus 80 square whole square. So this bracket is 80 square gone. You get 4a plus 4a upon t square bracket square, and this is 4 minus 4 comes out common, which becomes 16, then square of 80, no, this is plus, let me write it down, 80 minus a upon t bracket square. Is it correct? Up to this point, check whether algebra is correct up to this point or not. अरे ज्यांनी केलंय त्यांनी असंच केलंय का? Okay, there was a mistake in calculation. This sign here should have been plus, therefore this becomes plus 32a square, therefore this becomes plus 3a square, and we end up getting this equation 16a square, t square plus 3 upon t square plus a upon 1 upon t fourth. This looks like a perfect cube. If we take out t fourth common, then it is a perfect cube of t square plus 1 bracket cube. And now if we want to minimize this distance square, then we have to minimize this t square plus 1 bracket cube, and hence we write it as t square by 2 plus t square by 2 plus 1, and say that this quantity will be minimum bracket cube will be minimum AMGM inequality by AMGM inequality. All three of them should be equal. T square by 2 should be equal to 1. That is the condition that we get, which is t square is equal to 2 and t is equal to plus or minus root 2. So if t is equal to plus or minus root 2, then we will have the shortest normal chord, and its distance we can find out now. D square is equal to 16a square into t square, which is 2 plus 1 upon t raised bracket cube upon t raised to 4, that is 4, which is equal to 4a square, and this is 9. 36. What is given us? 36 a 9.
Sir, 3 cube.
Sorry, 3 cube. So this is 4 into 27. So 9 into 3 a square makes it 6 root 3 a. D is equal to. So minimum distance is 6 root 3 a. and t is equal to root 2. That is the most difficult problem in this set.